So hello guys, today I'm going to teach you formulas on thermodynamics basics. Those who want PDF of this thermodynamics basics, and you can comment your email ID in comment box. I will share you all this PDF. So without wasting time, let's start. So at first we'll see ideal gas equation. See here ideal gas equation. Ideal gas equation is PV equal to MRT. In other form, PV equal to nRT, PV equal to NKT, PV equal to rho RT, PV equal to RT. This important is the unity of this. So P is pressure, V is the volume, M is the mass of the gas, and R is the characteristics gas constant, and T is the temperature. And we'll see units. If we'll go to the units, P is in kilopascal and V is in meter cube, and R, this is universal gas constant. This is kilojoule per kilo mole Kelvin, and this R equal to R of an molar mass. Okay, this unit is kilojoule per kg Kelvin, and mass, the unit is kg, and this is the n, this is the mole. Okay, and rho, density, then density is kg per meter cube, and T, it's a temperature, it's in Kelvin. So if you are using the ideal gas equation, you have to use these units: P in kilopascal, V in meter cube, M in kg, R in kilojoule per kg Kelvin, and T in Kelvin. Okay, if you are using this formula, PV equal to nRT, you can use N for mole and R for universal gas constant, that is kilojoule per kilomole Kelvin. If you are using PV equal to nKT, then what is N? N is the number of particles of gas, and K is the Boltzmann's constant, that is 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, so P equal to rho RT, where rho is the density of gas, and A is equal to nu RT. This is the uh, specific volume. Okay, specific volume, its unit is meter cube per kg. So what is n? N equal to capital N upon A, where A is the Avogadro number, 6.022 into 10 to the power minus 23 mole inverse. Okay, so by using this ideal gas equation, you can find this P1 V1 upon T1 equal to P2 V2 upon T2. So there are different processes in ideal gas equation. You will see that if it's constant volume processes, and or it is also called as isochoric process, it's also called as isometric processes. Here the volume is constant. If we'll use this equation, and this T will cancel out, so P1 upon P2 equal to T1 upon T2. Okay, P1 upon P2 equal to T1 upon T2. For the constant pressure process, this is also known as isobaric process or isobastic process. Here pressure is constant. You will cancel this P1 P2 in both sides. You will get that V1 upon V2 equal to T1 upon T2. For the constant temperature process, or also known as isothermal processes, where temperature is constant, you will cancel both sides temperature, then you will get P1 V1 equal to P2 V2. Means PV equal to constant. For adiabatic process means no heat transfer occurs to the walls. So Q equal to 0, Q transfer, heat transfer. In this process is PV upon gamma, PV to the power gamma is equal to constant, or T V to the power gamma minus 1 equal to constant. If we'll solve this, you will get that T2 upon T1 equal to P2 upon P1 to the power gamma minus 1 by gamma. Okay, this is fine. So next we'll go to next page. So one more process is polytrophic process. Polytrophic process is PV to the power n equal to constant, where n ranges from minus infinity to infinity. In general, it's n ranges from 1 to gamma value. So from this equation you get that P1 V1 to the power n equal to P2 V2 to the power n. So you can find the value of n, where n is the ln of P2 upon P1 upon ln of V1 upon V2. So here is the graph of all processes, and you can see this is the PV graph. So here this one is the isobaric processes where pressure is constant, where n value equal to 0, and then this one is the isochoric process, means constant volume processes, where n value equal to infinity. So this one is the isothermal processes, means constant temperature processes, where PV equal to constant, n value equal to 1, and this one is the adiabatic processes, where n equal to gamma. This is adiabatic processes, and in polytrophic process n equal to n. This is the slope of adiabatic processes is more than isothermal process. Here is the slope is negative slope. You can check the slope of constant volume processes. Here is the constant volume processes. This one is infinity, and constant pressure process. This line, the slope of this line is 0, and uh, if we solve the slope of isothermal process dp upon dv uh, at constant temperature, you can get the slope equal to minus p upon v, and slope of adiabatic processes equal to minus gamma upon p by v. Okay, so we'll move to next. What is the compressibility factor of real gases? We have seen to ideal gases, then now it is real gases. This Z equal to PV upon MRT. So this Z value is the compressibility factor. The amount it deviates from the ideal gas, that is the compressibility factor. That value equal to PV upon MRT. Next, we'll see Van der Waals equation, Van der Waals gas equation for real gases. This is P plus A by V square into V minus B equal to RT, where A by V, this term is accounts for intermolecular attraction forces, and this B accounts for the volume occupied by the gas molecule themselves. It's volume occupied by the gas molecule by themselves. Okay, these two are for the real gases equation. One is the Z equal to Pv upon MIT, and this one is the Van der Waals gas equation. And here is the some few pressure terms. You can see the 1 bar equal to 10 to the power 5 Pascal, that is also equal to 100 kilopascal, that is also equal to 0.1 megapascals. And what is the value of 1 atm? That is equal to 1 atmospheric pressure, that is equal to 101325 Pascal, that is 101.325 kilopascal, that is 1.01 bar, or 760 mm of mercury, or 10.3 meter of water, or 760 torr. So 1 torr equal to 1 mm of Hg, and this is one pressure unit. Another pressure unit, 1 kg force per centimeter square equal to 14.223 psi, that is psi means pounds force per square inch, that is also equal to 9.807 into 10 to the power 4 pascals. Okay, next we'll move. What is zeroth law of thermodynamics? It states that if two bodies are in thermal equilibrium with third body, then they are uh, in thermal equilibrium with each other. See, this one is the body 1, this thermal equilibrium with body 3, and this is body 2, and it is thermal equilibrium with body 3. This body 1 thermal equilibrium with body 3, body 2 thermal equilibrium with body 3. That's according to zeroth law. This body 1 and body 2 both are in thermal equilibrium. Okay, this is the zeroth law. Okay, then there are some various way of the measurement of temperature. So This two types before 1954. This they used to take two reference points. One is steam point, that is 100 degree Celsius for water, and ice point, that is 0 degree Celsius for water. Okay, this is steam point and ice point. There's two reference point. So the temperature is calculated as T equal to AX plus B, where X is the thermometric property. I will say what is thermometric property. So here is the thermometric property listed here for the different types of thermometer. If it is constant volume gas thermometer, then thermometric property is the pressure. For constant pressure gas thermometer, the thermometric property is the volume. For electrical resistance thermometer, the thermometric property is the resistance. For thermocouple, thermometric property is the thermal EMF. For mercury in glass thermometer, the thermometric property is the length. And this thermometric property is X here. So T for temperature is calculated as AX plus B. If we'll put this steam point value in T and our ice point value in 0, and if you have thermometric property, that steam point, that XSP and XIP, it's steam thermometric property at steam point, thermometric property at ice point, then you will get this equation T equal to 100 into x upon x minus x at ice point upon x at steam point minus x at ice point. Okay, this was the earlier equation before 1954. They used to follow this equation, but after 1954 we used to follow a single reference point, one reference point, that is triple point of water, that is 273.16 degrees Celsius. And how we used to calculate the temperature? The temperature is T equal to 273.16 x upon x at triple point, where x is the value of thermometric property when that body is placed in contact with water at its triple point. Okay, when that body is placed in contact with water, then we will get some thermometric property. That is, if we will use that xTP, and then we can get that temperature. Okay, so there are the different temperature scales. You can see the like Kelvin scale, Celsius scale, and Fahrenheit scale, and Rankine scale. You can relate with this scale, like Kelvin scale and Celsius scale can be related with that. The temperature at Kelvin equal to temperature at degree Celsius plus 273.15. Temperature at Fahrenheit equal to 9 upon 5 into temperature at Celsius plus 32. The temperature in Rankine equal to 1.8 times temperature in Kelvin. So this is the general formula. F minus 32 upon 212 minus 32 equal to C minus 0 100 upon 100 minus 0, that is equal to Rankine temperature minus 0 upon 80 minus 0. This is the general formula. So all this formula is related to the thermodynamics basics. I have already said in quick way so that you can uh, revision all this formula. And if you want the PDF of these formulas, you can comment in comment box. So you just comment your email ID, I will send you personally. So if you like this video, you can hit like and share and subscribe this channel. Thank you.